Hey, what's up guys? This video is for section 7.2, which is division properties of exponents. So we are going to continue with 4 more properties. In my previous section on the video 7-1, I showed you guys 3 properties. So if you haven't seen those, you can go back and watch that video. But today we are going to talk about properties 4, 5, 6, and 7. So let's go ahead and look at property number 4. So we say these are division properties because you are going to start dividing some monomials. You're going to have a fraction, you're going to have variables on the top, variables on the bottom, or you might have just a regular constant, a number, but you guys will have division. So property number 4, which is called the quotient of powers, it says that if you have a fraction like this, and on the top and the bottom, numerator and the denominator, they have the same base, you guys are going to subtract the exponents. So I'm just going to read here on the right side, and it explains how to use the property in a fraction. If you have the same base, subtract the exponents. Now, the way you guys do it is you are going to take the top exponent minus the bottom. No matter what, you always take the top minus the bottom. Property number 5 is called the power of a quotient, and this is where you guys have a fraction inside of parentheses with an exponent outside. Now here, with the fraction inside of parentheses, distribute the exponent, the one outside of the parentheses, to the numerator and denominator exponents. So what this means is you guys will look at the exponents of each base inside of the parentheses. So let me just zoom in here so you can actually look at this a little bit better. A inside the parentheses has an invisible 1 exponent. B has an invisible 1 exponent. So you guys are going to multiply the one outside, this one, times the one inside. So 1 times m is m. Notice I keep the same base. A is right here, and m times 1 is m. On the bottom, you also multiply because the b is also inside of the parentheses. You keep the same base, b and b. And we have 1 times m is m. So we have a fraction, a to the m power divided by b to the m power. Now notice the bases are not the same here, so you're not going to subtract the actual exponents. Something else I forgot to mention on the previous property and this one is in fractions, the number underneath, which is the denominator, cannot equal to 0. So same thing over here. If you guys have a fraction, this is a cannot equal to 0 because any fraction with the 0 on the denominator, that is undefined. So we don't know what the answer is. It's undefined. So you have to have something else other than 0. So a 1 or maybe an m, whatever variable, whatever number, but it cannot be 0. Now property number 6 and 7, they're not really fractions, but these are also properties for exponents. So let's go ahead and look at property number 6. It says the 0 property, and it says any number or variable in that matter other than 0 raised to a 0 power is always 1. So the answer is equal to 1. So a to the 0 power, it equals to 1. If you guys have a number, let's say 3 to the 0 power, that's going to equal to 1. Now a, or the number, the base, cannot equal to 0 because you cannot have 0 to the 0 power, but anything else raised to the 0 power is 1. And the last property, property number 7, negative exponents. You guys will start having negative exponents. Is if we have negative exponents, you are going to make a fraction and write the number with the positive exponent on the denominator. If the denominator is the one with the negative exponent, I'm going to show you guys what to do to get rid of the negative exponent. But this is something I tell my students in class. Imagine that you guys have an actual fraction. So the a, I'm going to put a 1 under. That's going to make it a fraction. So a to the negative m power over 1. Look what happens. It's kind of like the reciprocal. So I'm saying kind of because it's not the actual reciprocal, but when you have the negative exponent, you need, if it's on the top of the fraction, you are going to move it to the bottom of the fraction. And you notice that 1 here, it kind of goes to the top. But I'll explain furthermore because there's some shortcuts you can use when you have negative exponents. But you have to know that if you have a negative exponent, you have to get rid of it because our answer cannot have negative exponents. So notice one more time, the a to the negative n power goes to the bottom of the fraction, and you guys make the exponent positive. Now a, the one on the bottom, cannot equal to 0 because in fractions, the denominator cannot equal to 0 because if it does, it's undefined. So I want to practice the properties with you. I'm going to start using one property at a time, and then I'm going to show you guys how to simplify an expression when you can use 1, 2, or 3 different properties to actually simplify the expression. But let's look at these examples here. We want to simplify. We want to do whatever we can in order to use the properties of exponents. So the first one, you guys have 3 to the 11th power over 3 to the 5th power. Now you guys have to understand why we can subtract the exponents. So I'm going to do this the long way first, and it's going to help you guys have a visual of what happens to the actual numbers, the basis of 3's. But then later on, I'm going to stop using the long way, and I'm just going to show you guys a shortcut. So if you guys take the fraction, so I'm going to make my fraction here, and you actually expand this expression. We know that 3 to the 11th power is you multiply the base by itself 11 times. So I am going to write down 3 times 3 times 3, you multiply by itself 11 times. So you notice that on the top, I have 3 times 3 times 3 times 3, you multiply by itself 11 times. On the bottom, I'm going to do the same thing, but I'm going to multiply the base only 5 times by itself. So notice on the bottom, we have 3 times 3 times 3 times 3 times 3. That's 5 times multiplied by itself. So if you pay attention to the fraction, you do have division. You are dividing. You have a fraction. You are multiplying all these numbers. But if you look at the first sets or pairs of 3's, this right here, you can actually simplify those numbers. Now you can do that because you are multiplying all the numbers together. If you guys are adding the numbers, this cannot be done. Only when you guys multiply a number or a variable in a fraction, you can actually simplify the bottom and the top. So 3 divided by 3 is 1. So that's going to turn into 1. Notice the next one. 3 divided by 3 again, it's also 1. And look at the next one. 3 divided by 3 right here, it's also 1. So guess what happens to the next one? 3 divided by 3 is 1. And the next one, 3 divided by 3 is 1. So on the bottom, we don't have more 3's that you multiply to cancel or simplify the 3's on the top. So that's what we have left. On the top of the fraction, notice on the top, we have 3 times 3 times 3 times 3 times 3 times 3. Now, if you guys use an actual exponent, well, count how many 3's you have. How many times are you multiplying the 3 by itself? Here's 1, 2, 3, 4, 5, 6. So we have 3 to the 6th power. And guess what? 11 minus 5 is 6. So I'm going to write that down. You guys will have 3, and I'm just going to show you guys the subtraction 11 minus 5, and that equals 3 to the 6th power. Now, you might be asking, well, what happened to the bottom of the fraction? Since the bottom of the fraction simplified to 1, and we don't have anything else, so all of this actually turns into 1. So you can put a 1 under the fraction, but you guys don't need that 1 under the fraction. So you guys can say this equals 3 to the 6th power. Now with the calculator, you can actually simplify 3 to the 6th power, and that equals 729. So let me just put that underneath here. It equals 729. Now in your class, you just have to ask your teacher what type of answer does your teacher want. Maybe they want the answer in exponential form, so you guys have the exponent 3 to the 6th, or your teacher wants to use the calculator and simplify to the actual answer. So just make sure you guys ask your teacher. So that's how you actually use the property of exponents. I'm going to show you guys the next one, and I'm going to use the long way again because I need to show you the shortcut that you can use when you guys simplify using property number 4, which means you subtract the exponents of the same basis. Now notice here, the fraction, we have the same base again. We have a c to the 8th power on the top and c to the 3rd power on the bottom. So they have the same base, c and c. So mathematically, property number 4 says we can subtract the exponents because they have the same c. But let me show you what happens when you guys actually do the long way. So I'm going to expand the top and the bottom. So you see those variables on the top and the bottom, I already expand. I'm going to start simplifying to 1. So this, you guys can simplify to 1. You can simplify to 1. They can simplify to 1. We don't have anything else on the bottom. So how many c's do we have left? 1, 2, 3, 4, 5. And you're multiplying all those c's together. So that means your answer is c to the 5th power. But notice again, the variable c, the ones that are left, the ones that didn't simplify to 1, are on top of the fraction. So I'm going to put a c on the top of the fraction, and I'm going to put 5 because you guys have 1, 2, 3, 4, 5 c's multiplying each other. If you subtract 8 minus 3, that equals 5. Now on the bottom, you guys don't have anything else, so you guys can say that we have an imaginary 1. We don't need it, so our answer is c to the 5th power. You cannot use a calculator because we have a variable, not a number. The next one, I really want you guys to compare with the previous example with the c's here because the answer is a little bit different. You guys do subtract the exponents, but I told you guys that property number 4, when you subtract the exponents, you always subtract the top minus the bottom. So 4 minus 7, that's a negative exponent. 4 minus 7 will be negative 3. But I'm going to show you guys what happens when you actually expand and you can have a visual of the m's and when you simplify to 1. So let me expand that expression. So there's my fraction with the m's multiplying each other. I actually expand m times m times m, and you multiply depending on the exponent by itself, the base by itself. So let's go ahead and simplify. This m divided by m, that's 1 because you guys actually turn that into 1. Anything divided by itself, it equals 1. M divided by m is 1. M divided by m is 1. And m divided by m is 1. Now, pay attention. You notice that on the bottom of the fraction, that's where we have the actual m's that are not simplified to 1. On the previous one, we have the c's on the top of the fraction. So here, you guys have to keep the m's on the bottom. And when you multiply m times m times m, you're multiplying the base by itself 3 times. That's going to be m to the 3rd power. So I'm going to have my fraction, m to the 3rd power on the bottom. And on the top, you guys don't have anything else because this turns into 1. Now, that's going to be your number on the top of the fraction, the 1. Even though you guys don't have anything else in a fraction, if you have an invisible 1 or everything turns into 1, you must keep the 1. Once again, I'm going to repeat myself there. In a fraction, if you have one on the top of the fraction, you have to keep it in your answer. Over here, notice that the c's, they were on top of the fraction. On the bottom, we had that invisible 1. So in a fraction, you don't need the 1 on the bottom because we know that any number that doesn't have a fraction, it actually is divisible by 1. So we don't need it. So my answer here is c to the 5th power because the variables were on the top of the fraction. Over here, my answer is actually 1 over m to the 3rd power. So I'm going to put a box right here. Also, go back to the actual expression over here. I want you guys to look at the exponents. Let's look at this one here. Where is the highest exponent? On the top of the fraction. 8 is the highest exponent. So that means that your answer is going to have the variables on top of the exponent. You keep the base where the highest exponent is at. Over here, same thing. The highest exponent is on the bottom of the fraction. 4 and 7, the highest exponent is 7. So you guys will keep the base on the bottom of the fraction. So that's the trick. When you guys want to simplify and you're dividing the same bases, you look for the highest exponent. You're going to subtract the exponents, but you guys are going to keep the base where the highest exponent is at. Now, the trick also tells you, remember that I told you, let's go back to the beginning of the video. Property number 4, you guys need to subtract the top minus the bottom. The trick is, if you look for the highest exponent, you guys keep the variable where the highest exponent is at, but when you subtract, you don't do the top minus the bottom. The trick is you just subtract the highest number minus the smallest number. So you always do the highest minus the smallest. That's the trick, okay? So this is only takes practice. You need to practice your properties of exponents to get good at it. If you don't practice, you are going to get confused. So let's try the next one. So here, you guys actually have the expression with more variables, and we actually have coefficients. So I'm going to use the shortcut that I showed you guys with the highest exponent when you subtract the exponents. But since we do have coefficients, first we need to look at those coefficients. 8 over 2. Imagine all of this is gone. Okay, you just have the fraction 8 over 2. 8 divided by 2. What's 8 over 2? It's 4. And if you guys actually simplify, you can say it simplifies to 4 over 1. Let me just write it down so you guys can see it here. 2 goes into 8 4 times, and 2 goes into 2 1 time. But guess what? That 1 on the bottom, we don't need it, because any 1 on the bottom of the fraction, you don't need it. You can have it as an invisible 1. But we do have more bases. So let's look at the next base, which is the variable g. Now we do have a g to the third and g squared. G to the third on the top, g squared on the bottom. Where's the highest exponent? On the top. So that means, and this is the trick I showed you guys, that means you keep the variable g on the top and you subtract the exponents. 3 minus 2 is 1. So you keep the 1 on the top. Then you guys look at the h, the next variable, the base. So the h on the top has an invisible 1. The h on the bottom has an 8. Where's the highest exponent for the h? On the bottom. So that means you keep the h on the bottom of the fraction, and you guys subtract the exponents. Biggest minus the smallest one. 8 minus 1 is 7. So you put a 7 as the exponent. Now remember that we don't need that 1 on the bottom. You do need the h. So this will be 4g. We don't need that exponent of 1. It's an invisible 1. H to the 7th power. So that is my answer. Okay, so let's go ahead and look at the next property, property number 5. Property number 5 is when you have a fraction inside of the parentheses and you guys have an exponent outside. So first of all, property number 5 tells you that you guys can multiply the exponent outside times the exponents inside of the parentheses. You guys are going to keep the same basis, but you guys will multiply the exponents inside. So we're going to simplify the quantity of 3 over 5 squared. So first we need to know what exponents we have inside of the parentheses. So the 3 has an exponent of 1, the 5 has an exponent of 1 on the bottom. I'm going to take this exponent, the one outside, and I'm going to multiply by the one on the top and the bottom exponents. I don't multiply the base. I am not going to multiply 3 times 2. I'm not going to multiply 5 times 2. I'm going to multiply the exponent 1 times 2 and the bottom exponent 1 times 2. Common mistake I see in my classroom is students will multiply the top exponent, but they forget to multiply the bottom. So make sure you guys check. You need to multiply the top and the bottom. So I'm going to put the fraction here. We don't need the parentheses anymore. I'm going to keep the base 3 on the top, and I'm going to multiply 1 times 2. That's going to be 2. So I put the exponent of 2. And on the bottom, I keep the base of 5, and I multiply 1 times 2 again, and that's going to be 2. Now you guys can simplify those two bases. On the top, 3 squared. So I'm actually going to simplify. I'm going to simplify 3 squared. That's going to be 9. 3 times 3 is 9. And on the bottom, 5 squared is 25. So 5 squared, 25. So my answer is 9 over 25. It's a very good idea to check if you can simplify the fraction. 9 over 25, you cannot reduce, you cannot simplify. So we got the answer. Now, if you guys have variables, same thing, you are going to, and you have a parenthesis with an exponent outside, you are going to multiply the exponents inside times the exponent outside. Now, you also have to check that if you have the same basis in the fraction. Here we do not. P and Q are not the same variable, they're not the same base. So I'm not going to subtract the exponents. I can't, because they're not the same base. but I know that P on the top has an invisible 1. The Q on the bottom has a 3. So I am going to multiply this exponent 7 times the 1 inside and the bottom 3. So I'm going to keep my fraction line. There's the base P, and on the top, 1 times 7 is going to be 7. So I put 7 here. And on the bottom, we have a Q, and 3 times 7 is 21. So my answer is P to the 7th power over Q to the 21st power. And the next one, you have more variables inside of the parentheses, but we still have exponents and we have a cube outside of the parentheses. So let's understand what we have inside of the parentheses first. So the 5 on the top, it has an invisible 1 because you guys are multiplying 5 times x to the 5th. So this one has an invisible 1, 5 to the 1st power times x to the 5th. And the y also has an invisible 1. So I'm going to put a 1 right here. Remember that when you don't see anything in between the variables and the numbers, you're actually multiplying. By default, you're multiplying. The bottom, same thing. You have 2 times z to the 3rd power. This 2 has an invisible 1 exponent. So now you are going to distribute or multiply this 3, the exponent, times the 1 inside, this one, this one, this one, and this one for the z. All the exponents inside of the parentheses, you guys will multiply by the one outside. So I don't need the fraction anymore. I'm going to start with the base of 5, and I multiply 1 times 3. That's going to be 3, so there's the exponent of 3. I go to the next one, there's the x, and you multiply 5 times 3. That's going to be 15. And I go to the next base, there's the y, and 1 times 3 is 3. On the bottom, you guys have a 2, and you multiply 1 times 3. That's going to be my exponent of 3. And the next one is z, and 3 times 3 is 9. So now you guys actually simplify the coefficients, the numbers. We have 5 to the 3rd power, and 2 to the 3rd power. So 5 to the 3rd power, that's actually 5 times 5 times 5. You multiply 5 by itself 3 times, and that's going to be 125. You keep the x to the 15th power, the y to the 3rd power. On the bottom, 2 to the 3rd power. That's 2 times 2 times 2. That's going to be 8. And you guys keep the c to the 9th power. Now look at the bases, x, y, and z. Those are not the same variable. They're not the same base. So you guys cannot subtract the exponents. Over here, 125 over 8, you guys cannot simplify. And you guys got the answer. So all of this here is the answer. Alright guys, I'm going to have to do a second part for this section, so make sure you guys check that video out. And if you guys like my videos, you can always hit the like button. You can also subscribe to my YouTube channel so you guys are up to date with my videos. And also make sure you guys practice, and I'll see you guys later.